Hi there and welcome to Middle School Math with Dr. K. Today we're going to take a look at slope, how to find it on a graph, and how to find it from coordinates of points. Let's jump in. There are 4 kinds of slope you need to be aware of. If you have not seen anything about this, you might want to look somewhere else before you jump into this video. If you're vaguely familiar with slope, here's the basic information you need. The 4 kinds of slope are a positive slope for a line that's increasing or moving up and toward the right, a negative slope for a line that's decreasing and moving down and toward the right, 0 slope for every horizontal line, and an undefined slope for a vertical line. Today we're going to take a look at a couple different ways to find slope. Calculating the slope from a graph is actually relatively easy when you've already identified some points, like in this example here. Math teachers often use the terminology rise over run. And what that means is, for our slope, we need to know how much our line is increasing or decreasing, and how long it takes the line to do that increase or that decrease. So think of this like a road map. I want to start at point A, we'll call this A, and move towards point B. And I want to know how long is it going to take me, and how high do I have to go. To calculate my rise, for example, I want to move from point A and I want to go up until I'm even with point B. The question is, how far did I move up? I can count the squares, or think of it like city blocks. I'm creating a road map from point A to point B, and how far did I have to go? In this case, I went 12 units. From there, I'm going to move toward the right to B, completing my road map. Again, I count my distance, and I see that I've moved 4 squares, 4 units, or 4 blocks, and that gives me my run. So to write our slope, we call slope M, and we put the value of our rise, in this case, 12 is our rise, over the value of our run, in this case, 4 is our run. When we simplify, we have the value of the slope of this line. Another way to think of slope is to look at the change in the y value and the change in the x value. Let's take a look at that in the context of this example. Again, to find my slope, I want to look for rise over run, which means I need to move from point A to point B, and I can see that I need to go up and over, creating a road map. In this case, I go up 2 places, and I go over 6 places, which means my m, my slope, is 2 over 6, which simplifies to 1 over 3. Another way to find that would be to look at what these changes represent. The 2 represents the change in the y value. You'll notice that these points have a y value of -5, which increases to -3. That's a change of 2 units. The x values have a change of -3, which increases to +3, a change of 6 units. Sometimes you'll see this example here that says delta y over delta x. Those deltas, the triangles, are Greek letters. And what that means is, to calculate the slope, we want to know how much is the y value changing, and we want to put that over the amount that the x value is changing. Delta y over delta x is another way of saying rise over run. Once you have a feel for slope being rise over run, and then you move towards thinking about it as a change in the y value over a change in the x value, calculating the slope actually gets a little bit easier and a little more efficient because you don't have to have a graph in order to know the slope of the line. Let's look at this example. To get from point A, again, to point B, I'm going to create my road map. I'm going to increase, then I'm going to move to the right side. Now, because I know I'm looking for the change in my y value and the change in my x value, I'm going to identify that on my graph. The rise, in this case, is a change from -3 to 5, and I know that to get from -3 to 5, I had to have risen by 8 units. The run, or the delta x, is a change from -5 to +5, and I know that moving from -5 to +5 is a change of 10 units. In this case, even without counting each individual square to get my rise over run, I know that my slope is going to be 8 over 10, which simplifies to 4 over 5. Now, while that delta y over delta x helps us a lot when we're looking at a graph, it simplifies what we're doing, what happens when we have the coordinates of 2 points and we don't have a graph to work with? That's where this equation comes in handy. This is a way to calculate delta y and delta x. Remember, the delta y is just asking for the change in the y values. And how do you find the difference in y values? You subtract them. Delta x is asking for the change in the x values. And how do you find the difference in the x values? You subtract them. So let's do exactly that and look at this formula and how it can help us to find the slope more efficiently. Now, when you're looking at the equation in general, you'll see that there's an x2 and a x1 and a y2 and a y1, and those numbers, the subscripts, can get really confusing. All they're doing is identifying that you have 2 points. You have an x1 and a y1 and an x2 and a y2, and those are going to be important in calculating the slope. So, in this case, my first point is going to be x1 and y1, and my second point is going to be x2 and y2. Now, it doesn't really matter which one's which, but it does matter that each point has an x and a y and that they go together. So in this case, x1 goes with y1 and x2 goes with y2. Now, when we're plugging those into this formula, y2 minus y1, we're finding the difference in the y values. So my y2 value is 0, my y1 value is 4, and I'm subtracting them. My x2 value is 12, and my x1 value is negative 4. Be careful here that you still subtract, even though there's a negative 4. You end up with 2 negatives. That's important, and you can't change that. Now, 0 minus negative 4 is negative 4. 12 minus negative 4 is the same as 12 plus 4, which is 16, which tells me that my slope in this example is negative 1/4. That's how you can use this formula to simplify finding the change in y over the change in x, or alternatively, if you like to think of it this way, the rise and the run. So what's the big picture? What's the takeaway? What do you need to know today? There are 2 ways that you can find the slope. The first is using rise over run. That's what math teachers like to call the slope. Essentially, you graph your 2 points and you look for the rise and the run like a roadmap to get from one point to the next. If you don't have a graph, there's another way you can calculate it. Using the coordinates of 2 points, you can look for the change in the y values and the change in the x values. To simplify it, there's even a formula, and that formula can be found here. Now remember, the subscripts there can look kind of messy. You've got 2 y's and 2 x's and some 1's and some 2's. Essentially, you're using your 2 coordinates as points in 2 locations. So x1 and y1, x2 and y2. As long as you plug it into the formula appropriately, it will spit out the right slope. So that's all we have today. I hope this helps you to better understand 2 ways that you can find the slope of a line. Make sure you subscribe to my channel so you have access to all of the videos I'm posting for middle school math content. Thanks for being here, and I'll see you next time.